Yeah, so I'm going to be presenting on the idea of using optical coherence tomography to get a biomarker of neurocognitive health in multiple sclerosis. Importantly, I'm talking about this thing as a screening tool or a research device, but not necessarily a replacement of standard MRI imaging, right? Okay, so to start, it's important to note, like, what are we talking about here, right? So multiple sclerosis is a relatively common neurodegenerative autoimmune disease. In Canada, it affects about 1 in 400 people. Biomarkers are surrogates used to diagnose and characterize the disease and predict and track disease changes, right? So, um, you can diagnose or characterize different phenotypes of the disease, right? And you can predict or give a prognosis, and as well as, track disease progression, right? So you can track changes in the disease, how much worse has it gotten or even better, right? Have people been responsive to treatment and so on. In MS, if you want to talk about an imaging biomarker or a biomarker of neurointegrity, you essentially only are left with MRI, which is a very, very expensive device, right? Um, and this is why it's inaccessible to many clinics, right? For example, like a family clinic or even just like a lot of research settings, right? Because the machine can cost a couple $1 million, right? And it requires a lot of money to pay, people to operate the machine, as well as the operational cost of the machine itself, implementation of the machine, and it requires a lot of expertise to additionally analyze the data. It's very complicated, right? Conversely, OCT, may cost you a couple $1,000 as a machine. It's very, very easy to use. It's essentially almost automated, and you need very little training to actually be able to operate it. And data analysis is, to my understanding, simpler than MRI. So it's very accessible compared to MRI. So here's an example of what does an OCT, or what are some images an OCT can provide. OCT can give you all kinds of different images based on what is the eye looking at. Oh, I should have specified. OCT is looking into the eye, right? So we're looking into the eye, and it's important to know that the eye is an extension of the brain, right? So it's a biomarker of neurointegrity at large through looking at what has happened in the eye. And so here you can get like a cross sectional of the eye, and here's a little map. So picture like, for example, the optic nerve sliced down the middle, and we're kind of looking at it, or just its head, and this is like a thickness profile. So it's telling you thicknesses, right? And you want to be here. Um, uh, Too little of thickness is going to suggest neurodegeneration. Too much thickness might suggest inflammation, for example. Um, so importantly, mm, it's a fairly new technology, but it's not all that new. It's developed in the 90s by Huang et al. And has become pretty standard in ophthalmological practice for diagnosing all kinds of macular degeneration and so on, right? Um, and importantly, it gives very high resolution images, right? Like these things are exponentially greater resolution than MRI and ultrasound and X-rays, right? So it's pretty good for imaging. However, its major limitation is that you can only image structures which are accessible to visible light. For example, the first couple of layers of the eye, right? So that's why we can blast light in and image it, but we can't actually image, through the skull or look at the brain. And even if we did, hypothetically cut open the skull and, probe in there with an OCT or similar technology, we would only be able to see the first couple layers of brain because the light will not penetrate the whole thing, right? Um, uh, yeah. So this thing is exponentially higher resolution, which is good, But again, major limitation is it's only accessible to surfaces, which can be reached by visible light. In this case, it uses near infrared light spectrometry. Anyways. Okay. So, um, as I alluded to, the eye is considered an extension of the brain, and it develops out of the brain. It develops out of the diencephalon, right? which is actually a part of the prosencephalon, right? So your forebrain, right? And it connects in particular to the thalamus, the lateral geniculate nucleus, right? Um, and and there's numerous pathologies which are linked to disturbances in the retinal neurofiber layer and uh, just ganglia within the retina. You see all kinds of pathologies emerging as they relate to different psychiatric and neurodegenerative conditions. And in fact, people began to notice these abnormalities as they related to brain pathologies, like 150 years ago in France. And they were initially documenting these using an ophthalmoscope, which is that little black or handheld device that a doctor might use to look into your eye, right? And it basically just has like a little light and a couple of mirrors and a window, and he can just look into your eye and just look with his own eyes and see what is visible to the eye. And he was documenting all kinds of pathologies you would see with stroke patients and patients who have had a hemorrhage or inflammation in the brain or tumors, right? So yeah. Okay. Okay. So importantly, there's been a number of key findings along the way in the development of OCT as a tool to investigate the central nervous system in MS, right? So importantly, the retinal neurofiber layer has been repeatedly observed in people with MS to have degeneration, right? Um, and this is true even in those who haven't had optic neuritis or inflammation of the optic nerve, which occurs in about, I believe, about 80% of people with MS in their lifetime will experience optic neuritis. Again, inflammation of the optic nerve and of course, damage to it. But even in those who haven't had it, or who, if you image them prior to optic neuritis, they still show neurodegeneration within the retinal neurofiber layer, RNFL. And additionally, what you find is differences in the RNFL across phenotypes. Surprisingly, what you find is that those who have progressive types of MS actually seem to have better off RNFL. Um, However, what's the reason this is surprising is that progressive subtypes typically have worse disease outcomes. So it's interesting that in this case they don't seem to, but again, the idea of the biomarker being able to distinguish phenotypes is very important, in developing this as a biomarker. And also, the thickness relates to the standard EDSS neurological disability scale in MS and can even predict increases in disability 3 years, 5 years, and more recently 10 years, from imaging. And similarly, the thickness cross-sectionally and longitudinally relates to objectively measured cognitive dysfunction, right? So cross-sectionally would mean, it's relating to it at the same time point, and then longitudinally means you can predict changes in objective cognitive performance across time, right? And decreased RNFL thickness corresponds to overall functional brain matter atrophy, right? So specifically, like you look at the thickness of the RNFL within the eye, and what you find is that its thickness, its degeneration, its integrity is related to overall brain integrity, and more importantly, in MS, it's related to subcortical or white matter atrophy, right? And it's important to remember that MS is considered a demyelinating disease, right? So it attacks white matter, right? Myelin, right? And so importantly, the RNFL thickness is related to the integrity of the myelin within the brain. So who cares, right? Like what's the big whoop? So what is now possible using OCT is that many researchers and maybe one day clinicians are given a meaningful proxy of neural integrity and neurological disability, which is fast, easy, and inexpensive to use. And importantly, of course, this is solving the problem of inaccessibility and impracticality of using MRI. Personally, I hope to use OCT metrics to assess how subjective and objective cognitive measures and their discrepancies relate to RNFL thickness in MS, and possibly something called OCTA, which is angiography, and it measures blood flow within the eye, possibly as a proxy of overall brain blood flow. And I plan to investigate how RNFL thickness relates to nerve conduction speed in the corticospinal tract, as measured through transcranial magnetic stimulation, motor evoked potential latencies in MS. So, in simple terms, I would like to see how might the RNFL thickness relate to the integrity of the corticospinal tract, so that the tract running from the cortex to the spinal cord all the way down to muscles where we measure a response. So specifically what you do with the TMS is you basically run a current from the motor cortex through the corticospinal tract all the way down to a muscle group, and you just measure the responsiveness. And you can measure conduction speed by how quickly does it travel, and there's other things as well as like how well does it carry a current in terms of carrying that intensity. So yeah, here's some references, and I'd like to ask if anyone has any questions.
Yeah, I have a question. About MLS. How effective do you think this will be if it detects like OLI? Do you think there's because currently there's no treatment for MLS, but there's pretty standard protocols that need to be taken. What do you think that will happen on the healthcare system if we can detect this early?
If we can detect MS more early, you said?
Yeah, like an early and efficient. What do you think would happen with regards to planning and preparation? Because a lot of these people end up in long-term care facilities given there's no treatment. Like,
yeah, there's no like drastic treatment which may drastically modify the disease course, or at least there's nothing which is standard practice. There's experimental treatments, right? So but in terms of like, there are a lot of people who are on what are called disease modifying therapies, right? So these are a class of drugs which can actually alter the disease course, and they're more effective if implemented early. So of course, if OCT could maybe help screen us for who needs better MRI, better assessment earlier, right? Because you have long wait lists for people who want to see neurologists. If you can screen people and more efficiently determine who needs to be fully assessed, yeah, maybe you could get them on DMTs sooner, and other treatment plans, right? Like, it's very important to recommend exercise to these people. Exercise is really, really good for preventing cognitive decline, and as well as increasing neurological disability, and loss of like upper limb extremity functions, and all kinds of things like that. So, and mobility, like exercise is really good, but also like disease modifying therapies early on are really good. And I've seen people even suggest that heavy vitamin D supplements may help if implemented early in the disease course. So but yeah, there's nothing that is like a miracle cure. But with early screening and good biomarkers, you can better track changes, and hopefully screen for who needs treatment sooner, right? Who gets triaged, right? That's a good question, Jason. Thank you. Or yeah, Jason. Sorry, I almost said Stephen. Okay. If there's no more questions, I'll just stop the recording. Okay. Okay, Maria.
Is there like a genetic?
Oh, sorry.
Is the disease like connected to genetics as well?
Yeah, like I believe it's more common in certain groups, but like the main thing is, one, like it's an autoimmune disease, so it's like very random, right? It's like cancer, right? A lot of things like autoimmune diseases, I think, are well compared to cancers in the fact that it's like there's risk factors, but it at the end of the day seems fairly random and just unfortunate. But one of the strongest risk factors, to my understanding, is vitamin D deficiency, right? So vitamin D deficiency is an important factor in determining both the severity of the disease and who is more likely to get it. That being said, like basically everyone has vitamin D deficiency, right? Is vitamin D deficient. And according to Maria, I'll cite Maria and the medical lab technologists I know, vitamin D is not used in blood work anymore because it's like it doesn't really give you anything because everyone's vitamin D deficient, right? So it doesn't tell you much about health if everyone, you know, is being measured the same way. But yeah, the more vitamin D deficient you are, the more likely you are to get it. But in terms of etiology, I don't know. My understanding is it's fairly random. But the best things you can do is just try to live a healthy life in terms of exercise, good diet, and sunlight exposure while wearing sunscreen. Mhm. Maria, do you want to add anything?
I guess I could add that the vitamin D test that Aiden was talking about was just like the indications for testing were changed, but that's like a provincial thing. So I don't know about other provinces and how they
Yeah,
test for vitamin D, but I just know that like basically like now we have like probably 30% of the tests coming for vitamin D. So basically it's just like if they're I think at risk for MS or something, but before you can just test anybody for vitamin D levels, and it just doesn't give a lot of medical. There is not a lot of medical relevance to that anymore because everyone's deficient.
yeah. I know like they gave it to Sadat in Singapore, and maybe, you're closer to the equator and it means a little bit more, but like in a place that's so far north, like everyone is going to be vitamin D deficient, right? Because it's hard to get adequate sunlight. Hey, I think I'll log off if unless anyone wants to share anything. Jason,
No,
would
this
you
is
be interested? Jason, would you be interested in someday sharing with us some cool like history analyses? I feel like you would have a lot to